Greetings, detectives. Mrs. McKay here. I'm going to warn you that this is going to definitely take 2 videos just because it's too much information. But let's get started. We're on clue 3, and this is case 4. And our learning target clue is I can represent an arithmetic sequence with a recursive equation or an explicit equation. I can represent an arithmetic sequence with a recursive equation or an explicit equation and use each equation to find the nth term. All right, you're going to need your student assignment book. You're going to need page 55 because we're going to do some problems out of that book. But before we do anything, let's go over some terminology. We've been talking about arithmetic sequences. Arithmetic sequences are a series of numbers or a list of numbers that have a common difference. That means something that gets added to each term to get the next term. And it's always the same thing. It's constant. So we can use letters to represent an arithmetic sequence, and typically the letter that's used for an arithmetic sequence would make sense is A. A represents the arithmetic sequence, and each term in the arithmetic sequence is represented by the letter A and then a little sub number underneath it. And so the first term of a sequence would be represented by A sub prime. That's a 1. I'm having a hard time writing today. And all remaining terms would be A sub 2, A sub 3, A sub 4, and so on. All right? And if we have an unknown term, a term that we are going to try to find, maybe it's the 100th term or the 10th term or the 16th term or the unknown term, we call it the nth term, so A sub n. All right? And if we want to know, often when we're figuring out a term, we have to know what the previous term was. We know what one term is, and then we can find the next term. So to find the next term, we have to know what the previous term was, and the previous term is A sub n minus 1, which just means that if I want to find the 10th term, I need to know what the 9th term is. If I want to find the 20th term, I need to know what the 19th term was. So I always have to pick the term right before it and then add my common difference. And the last thing is the common difference is going to be represented by the letter D. So all of those things make sense, don't they? Let's go on. Let's read our problem. So this is on page 55. If you haven't gotten your book yet, pause the video, go get it. Greta must volunteer 225 hours for a community service project. She plans to volunteer 6 hours each week. So the sequence shown represents the number of volunteer hours she has left after 3 weeks have passed. So she started with 225, so that's our first term. And then after her first week, she had only 219 hours to work, because it looks like she subtracted 6 hours from the 225. And then the next week, 213 hours, and the next week, 207 hours. What kind of sequence is this? Well, I think we can all see that it's an arithmetic sequence, so go ahead and write that down. And what is the common difference? Well, the common difference is we subtract 6 from each, so our common difference is minus 6, so let's write that here. All right? Now, these are the number of weeks, and so on 0 weeks, 0, she hadn't worked any weeks, she hadn't worked any hours yet, so for the number of weeks was 0, so there were 225 hours left that she still needed to work. And that's our first term, so I'm going to write a 1 there. All right, so that's our first term. Our term number is 1. And then our second term is 219, and that was after 1 week. And our third term is 213, and our fourth term is 207. I'd like you to go ahead and finish the rest of this table. Fill it in with the next three terms, the fourth, fifth, and sixth term. Okay, so hopefully you actually paused the video and did this and actually wrote in not the fourth, fifth, and sixth, because I had already done the fourth term, but the fifth, sixth, and seventh term. It was for the fourth, fifth, and sixth week. And now what I want you to do is I want you to notice a pattern. I want you to notice that we've got from the first term, which started at 225, how did we get to the second term? Well, we subtracted 6, didn't we? And then to get from the second term to the third term, we subtracted 6 again, or we added a -6. And from here to here, and from here to here, from here to here, each one, we added a -6. Now, the question that is asked in your book is, use a formula to determine how many volunteer hours Greta has left to fulfill her requirement after 33 weeks have passed. So I wrote down here how many hours left after 33 days, and I should have written weeks. So cross that out, cross the days out, and write weeks. And let's go ahead and see if we can figure out how many times we'll have to subtract 6 till we get to 33 weeks. All right, so we subtracted 6. Looks like we could fill in this pattern. We could continue to fill in this table, but we'd have to turn our paper over. We could write the week 7, week 8, week 9, week 10, week 11, all the way to 33. And then we could number all of the terms, 8, 9, 10, 11, 12. And what we would find is that on week 33, it is the 34th term, right? Can you see that? The on week 6, it's the 7th term. So that means on week 33, it would be the 34th term. So that's one thing. All right, so we're going to try to find the 34th term. We want to find A sub 34. We want to find the 34th term. All right, we want to know how many hours are left on the 34th term. So now let's see if we can find another pattern. What happens when we go from term 1 to term 2? Well, how many times did we subtract 6 when we got from, if we were going to do term 2? So if we want to know what term 2 is, how many times did we have to subtract 6 to get to our second term? Well, our second term is 219, and we subtracted 6 just one time, right? How many times did we subtract 6 to get to our fourth term? Well, our fourth term is 207, and we subtracted 6 1, 2, 3 times. 1, 2, 3 times. So to get to term 4, we subtracted 6 3 times. We added our common difference 3 times, right? So how many times for our 7th term, how many times, which happens to be 189, how many times did we add our common difference? Well, we did it 1, 2, 3, 4, 5, 6 times. 1, 2, 3, 4, 5, 6 times. So week 7, or not week 7, term 7, 6 times we subtracted 6. On term 4, we subtracted 3 times. On term 2, we subtracted 1 time. Do you see the pattern? We added our common difference, which happens to be subtracting 6. We added our common difference 1 less times than our term number. So I think we can come up with a formula. We can say that if we want to find the nth term, okay, we started with 225. So if we start with our first term, so we'll say A1, A sub 1. If we start with our first term, what did we do? Well, we started with our first term and we subtracted 6. Well, how many times do we subtract 6? Well, we subtract 6 the same number of times minus as our term minus 1. So our formula is to find a to the nth, a sub n. We start with our first term and then we add to it our difference, our common difference, which happens to be -6, and we have to multiply that common difference by 1 less than the term number. So what that means is I take, to find A34, A sub 34, I'm going to take my first term, which happens to be 225, and I'm going to add to it my common difference, which is -6, and I'm going to do that 1 less than my term number. So my term number is 34, so that means I'm going to subtract 6 33 times. I'm going to take 34 minus 1, and I'm going to subtract 6 33 times. Well, if I repeat addition, if I add -6 33 times, that's just multiplication. So I'm going to do -6 times 33, which is up here, just the 34 minus 1, n minus 1 right there, d times n minus 1. So go ahead and see if you can pull out your calculator and figure out what that is. Okay, so I took my -6 and I multiplied by 33 and I got -198. So I'm going to subtract 198 from 225 because I'm subtracting 6 or adding -6 33 times. So that makes it a -198. I'm going to add that to my 225 and I end up with 27. So my 34th term, which is my 33rd week, is 27. That's how many hours are left after Greta has been volunteering for 33 weeks. All right? So that's called an explicit equation, an explicit equation. And an explicit equation will help you find a specific term. You want to find the 3rd term, the 4th term, the 25th term, the 100th term. You can use an explicit equation, and this right here is what will help you to do it. Okay? Now, there's another way that there's another equation you can write, and that's called a recursive equation, the recursive equation. And recursive equations, you don't have to do any plugging in. You just have to know what the previous term was. The recursive equation is what we automatically do already. So what we do for a recursive equation, and the way that we remember it, is we take, if we want to find our nth term, we take the previous term, so a sub n minus 1. So if we want to find the nth term, a sub n, then we take our previous term, which is n minus 1, a sub n minus 1, and we add our common difference. So if I wanted to know what, in my little thing here, if I wanted to know what the 8th term was, a sub 8, in my problem about Greta, if I wanted to know what the 8th term in my sequence was, I would take the previous term, which is 8 minus 1, so that would be a sub 7, and I would add my common difference, which is -6. So a sub 7 is 189, and I would add my common difference, which is -6, which gives me 183 hours left. Come back.